start the webinar countdown timer now. Greetings to all. I am Daisy, and I will be the webinar moderator. Welcome to the 16th Masterclass Series webinar of the OMS eLearning Academy. Today's webinar topic is Lost Tangible Benefits in Refinery Operations, Ignorance or Indifference. We have an overwhelming response from many countries, and we welcome you all. And hope you all will have a very informational and interactive session today. Before we start, let me discuss a few house rules. The webinar will be 40 to 45 minutes long with a 10-minute Q&A session. You can enter your question in the chat box during the presentation, which will be answered at the end. The webinar will be recorded and available on the OMS eLearning Academy website. There will be a 2-question poll at the end for your input. Please give us your candid feedback at the end via the redirected Google form. About the speaker's organizations, Offsite Management Systems LLC was founded in 1998 in Houston, Texas. Its charter to provide consulting and refinery automation project executions worldwide. OMS eLearning Academy was founded in 2018 to provide continuing education to professionals working in the downstream refining industry and related businesses via the eLearning platform. This webinar will teach you 3 concepts related to the lost tangible benefits of refinery operations. Ignorance or indifference. First, understanding the stakes in refinery operations involves recognizing the significant financial, environmental, and operational risks. This section emphasizes the tangible and intangible assets that can impact oversight failures, including profit margins, compliance costs, and long-term viability. Secondly, this part dives into the root causes of inefficiencies within refinery operations. It connects the dots between minor oversights and their substantial effects, revealing how small missteps can cascade into more significant issues, ultimately impacting performance, safety, and profitability. Last, this section encourages self-assessment among refinery operators and managers. It aims to foster awareness of existing gaps and inefficiencies in their processes, inspiring actionable insights for improvement. The journey to self-realization is about understanding limitations and actively seeking optimization solutions. Thank you all for attending this informative webinar. To appreciate your efforts, we have 2 complimentary gifts for you. Please stay until the end to learn about them. With this, let me request the webinar speaker, Dr. Agrawal, to start the webinar. I will be back at the end of the presentation. Thank you.
Good morning, everybody, and apologize for overlook on my part to share the sound. This is very informative webinar, and a lot of things come from my personal experience working in the industry with many refineries. And one of the questions was always that despite the benefits that are recorded and recognized in industry, why still is big ignore and people are showing indifference? So I'm trying in this webinar to give a little bit knowledge of those aspects. First, we'll start with refinery volatile profit margins. Over the decades, refinery has been suffering profit margin, and even today it's very low, between 3 to 7% net margin. And we'll see some of the reasons why they are so. We'll compare with the on-site versus off-site operation to clarify some of the myth that sometimes people in the industry have, that when I talk about off-site, they immediately say, oh, it's utilities. In fact, which is not. So we'll clarify some of the misconceptions in this area. What are the key profit driving areas? We'll discuss, and we'll go a little bit in detail to appreciate that it's a lot of money on the table to grab it, and it's quite tangible. Then we'll talk about ignorance versus indifference. Now, if I offend any of the audience for some of the statement that I'll make, please don't mind it. This is a very objective type of webinar where I'm trying to list all the causes and what can you do about it. We'll uncover hidden cost, potential benefits areas where the benefits are lying. We'll then talk about it, how to estimate those tangible gains. There's one thing to talk about, okay, there's a lot of money on the table. But second thing is, okay, how do you claim them? What can you do to claim those benefits? Then why the management of the refinery is sort of indifferent about this barrier. So this tangible benefits. So we talk about how to overcome those indifferent barriers. Then we'll talk about practical support and solution. So if you look at the profit margin of a refining industry since 1977 2009, you can see the gross margin is anywhere 10 to 12%. It's reached at some points, but those gains did not translate into net profit. And the reason being the consistent high cost of operation. So that affects the profitability. And by the time they are done, the net margin is very near zero or sometimes only 3 to 7%. And even though the chart is showing up to 2009, the data is available, but the continuous, sorry, the thing continues in the current era also. Let's talk about last 5 decades. What are the reasons why this refinery margin is so volatile? Starting in the 1980s, it was the oil crisis, geopolitical tensions, and regulatory changes. The next decade of 1990s, there was the market deregulations, technological advancement, and increased competition. 2000, the crude price were rising. There were increase of environmental regulations, demand fluctuation. 2010s, Shell oil boom, if you all remember, and it was a tightening fuel quality specification. The Shell oil project failed the next decade because of economy was not working well. In 2020s, now we had the 2 years of COVID-19 pandemic, and then energy transition pressures from clean energy to green energy, carbon reduction initiative, digital transformation. So these are the reasons that the industry profit margin is volatile. And still, even 2020s, this decade, you're going to see the pressure from energy transition and digital transformation action will continue to impact margin. So refinery margin has been affected by many factors over the last 5, 6 decades. And it's not, any comfort in this decade. The challenges are still continuing. So what can we do to improve profitability amid margin volatility? Refineries can do the operation efficiency. They can leverage advanced control systems to optimize production, implement predictive maintenance to reduce downtime, equipment failure, and focus on energy efficiency improvement to lower operating costs. Second thing, refineries can do the digital transformation and AI, and we are seeing a lot of those initiatives in the industry, not only refining but all the industries, which are utilizing AI and machine learning models for real-time data analytics and decision making, adopt digital twins for process optimization and forecasting, and then implement data-driven optimization in blending operation. I'll touch some of those ideas about AI and machine learning in this webinar. Then we have the initiative for net zero and carbon initiation, minimum carbon initiation. And we have much about the Paris Agreement and other things. So refineries down the road have to meet those carbon reduction initiatives to meet new regulatory demands and optimize the fuel quality specification to meet environmental standards. Focus on energy transition to adapt to future market shifts. So these are the 3 areas that some of it is being done now and some of it can be done in the coming decade. So implementing this strategy can help refineries convert gross margin into sustainable net profit, even in volatile markets. So now, what are the areas, 2 areas of the refinery that really impacted by this one? So we all know the on-site operation. On-site operations are where all the process units create and manufacture components, products. These products are not sold by themselves. We're talking about you need like distillation column, FCC, isomer, and all the things. But they do create components which goes to the off-site operation to create the final product, like the fuel, gasoline, diesel, fuel oil, LPG. And those are the products which are sold in the market. And that's where the refinery makes money or loses money. And those areas can be blending optimization, storage and tank management, product scaling, logistic, inventory management, oil movement, and then compliance, environmental management. So the offsite area, which is unfortunately ignored uh, by so many refineries because it's not considered very important, they focus on more on on-site. And we'll discuss more on this topic, that where really the money lies. So achieving sustainable profitability analysis requires a dual focus on both refinery on-site and off-site. Now, there's a belief that, okay, we can make more money on on-site operation than off-site. Let's wait a couple of slides on that one. So where does the refinery profit come from? Now, if you look at this chart, the on-site operations have only one-time profit. They do the optimization, they do put all kinds of high-end software, but that profit is only one time. Versus off-site is a recurring profit because they have to make the product and they have to sell the product. And they don't sell the product correctly or give away, then they lose money. And this is about $40 to $80 million range. Now, and this is, you will see, where do we get this $40 to $80 million yearly benefit from offsite operation? So let's understand the lost reason for the lost benefits in refinery operation. Now we have 5 factors here: data and measurement inaccuracies, which is 10%, scheduling and operational delays, equipment failure. But these are not due to any of these ignorance factor. Ignorance factor, which is lack of awareness, training, is 30%, and indifference, resistance to change, is 25%. So to do away with this thing, refinery need to invest in training to reduce loss, because unless your employees and professionals are not trained, they cannot be very much skilled or aware of what they're losing for the refinery. Then indifference comes the culture of continuous improvement. And this is focusing more on the management, that they have to recognize and accept the changes. And we'll go more on detail in this slide. So by addressing these factors, ignorance and indifference, refinery can reclaim up to 50% of lost tangible benefits. So this is a lost potential, big potential to achieve for refinery operations. Now, so people ask me, okay, when you talk ignore factor, what is ignorance factor in operations? Ignorance factor is lack of awareness and having outdated knowledge. These are the two major reasons for ignorance factor in operations. Failure to recognize impact, culture, complacency, limited exposure, absence of data-driven. They're as important as the first two, but have a less impact. The reasons for this: outdated training and skill development, organization silos. There's too many departments which never talk to each other. They don't know what left hand is doing with the right hand. A resistance to change. I heard again and again, if it's not broken, don't fix it. Lack of management focus to on-site operations. Lack of access to modern technologies. Inadequate data analysis capabilities. Evolving industry standards and compliance regulation. On a point here, I had presented a paper in Delhi on 9th September, and there were about 600 people from the industry. And my interaction with them was the same thing. Why refinery ignoring the benefits and why are they indifferent? And they had some insight and some reasons. And those reasons are sort of put together in this webinar and to give you the first-hand information, why those reasons are. So we have, what are the areas of focus for increasing the efficiency in refinery operation? We start with the fuel blending, which everybody knows brings about 50 to 55% of the products in the end. Oil movement, tank form, terminals, mass balance. Mass balance is sometimes called as the oil loss, maintenance cost, environment, and technology. So all of these 8 areas are have their own importance. That how much money do they bring on the table in terms of tangible benefit, and we'll go in detail one by one. Let's start with fuel blending. Now I've talked about this concept over many webinars, but we'll make it a very short here. So what are we losing here? We're losing benefits in terms of product quality and reblending cost, increased energy use and lower yield. Inefficiency in terms of manual suboptimal recipe, inaccurate blending ratios, and outdated blending technology. And the benefit are about $22 to $24 million, say $20 to $25 million per year. Now, all these numbers that I'm showing you on these slides, in future slides, they are not a fake number. They are really have been proven in the industry from OMS experience and from your own experience too. Let's go to next area of oil movement. Now, in terms of oil movement, we are losing benefit in terms of product contamination and higher operational costs, inefficient of infrastructure, and excessive energy consumption. If you look at the oil movement, there are lots of movements occur every day, from tank to tank, from tank to ship, ship to tank, whatever. It's about 12 to 13 types of different movements. And out of those, tank to tank is the highest number of transfers in a refinery. So if I'm talking about 300,000 barrels per day refinery, in a day, about 100 to 200 movements take place. And there are some manual and some are automated in a modern refinery. So there's a lot of inefficient routing and scheduling, underutilization of tank case because fear of spills, and contamination from product mixing. And when these product are contaminated, they are going to slow. So it's about $3 to $10 million per year. Now, I need to point out this thing. A lot of refineries take the blending upgrades and the oil movement upgrades separately. Now, OMS has done many studies of oil movement, and at the end of the day, we find that oil movement does not have enough incentive to even those at $3 to $10 million because we're done separately. The refineries which they execute the blending and oil movement together, they achieve the maximum ROI. But that concept is lost, and they don't realize, and they cut corners that we'll do blending first and they'll do the oil movement, and they lose the ROI for the oil movement. Let's go to tank farm management. Now we lose the benefits in terms of increased energy costs, product degradation, higher emission, safety risk. Now emission comes only when you are loading the tanks and the vapor at the top of the tank liquid is lost to the atmosphere, and that there are regulations how much can you do. So they have to control that one and minimize the loading and unloading. Inefficiency spills during loading time. If it's not automated, it spills, and then it causes a lot of difficulties in cleaning up. Now, extended inventory. Now, inventory is in the liquid assets about $3 billion staying in the tanks. Now, it's like a money in your bank. If you don't move it, you don't get much interest in the bank. So you have to move it, invest it somewhere else. That's exactly the same concept in refinery. If you don't move the inventory either to customers or in a product, then you really losing money. Every day you hold them in the tank, losing money. And it's about $2 to $4 million per year. In terms of vapor losses, lack of proper insulation, and inefficient heating and cooling. Let's go to terminal operation. Now, terminal options are like a ship, a truck, and the barges, other things. Now, in terms of if the ship is delayed and waiting at the port, they have to pay the demurrage charges, and the ship get delayed because they might have to go to another customer. So, and also lost opportunities. If you don't sell product to the customer, you're losing opportunity in time, and the compliance fees, fines. In terms of inefficiency, poor scheduling. If the ships are not scheduled properly based on what is in the tank or what is required, then you pay the demurrage charges. Inaccurate product measurement, which is called custody transfer. If you don't have a right meter calibrated or installed, then it causes a legal dispute also. because somebody said that I gave you so much, and refinery said, no, I did not receive that much because the meters were faulty. And it can lose anywhere between $1 to $3 million per year. Let's go to the mass reconciliation now, which is also called as oil loss. Now, oil loss is measured from inlet to outlet. It means what you received at the inlet side in terms of the crude and product, and what products are you manufacturing and sell it to the customer. Now, I have seen many refineries we do the balance. Now, this balance is by a mass balance, which is called a mass reconciliation, because products are not lost between input and output. They have to be conserved. Now, I've seen the data from the refinery where they're showing as a negative loss. It means the mass is lost, which is not correct. And it's not correct because of the data reconciliation. So it's an inefficiency due to manual data entry errors with delays in reconciliation. They don't do it every day. They do it every month because a lot of work involved, and a lot of companies have tried creating a projects, $1 million projects where they want to do every day, and they failed. And I was unfortunately part of those kind of projects. So I've shown here the lower graph that if we take 0.01% improvement in oil loss, so typical average of oil loss is about 0.4 to 0.5%, which is a good average. Now, if you decrease from 0.5 to 0.049, you gain millions of dollars in terms of oil loss. Now, this is a real graph that I did for Shell Corporation. They had 8 refineries and different capacities. So this was the estimate that if we improve the oil loss by 0.1%, how much money we will save. And this was about order of $20 to $24 million per year. Yeah. We go next one to maintenance and equipment health. Equipments are have to be maintained properly. And I've seen the failure of pumps and valves in the blending, and then everything stops and the products are not dispatched to the customer. So you have to reduce equipment lifespan, unplanned downtime, and higher operation cost. Inefficiency, you're relying on a reactive maintenance. You fix it only when it's broken. But if you don't do a preventive maintenance, then you're asking for disaster, and then you're losing opportunity. And it's about $3 to $4 million per year. Then we go to environmental compliance, which is becoming a big thing nowadays because of the zero nets and carbon reduction and carbon initiative. And we have seen so many agreements. Now the loss benefit in terms of fines, because if you are emitting a lot of hydrocarbons, you will find so refinery are losing money from that point of view also, and also damage reputation of the refinery. Inefficiency, inadequate emission control, lack of real-time monitoring, inconsistent adherence to regulatory standards, and it's about $1 to $8 million per year estimate. Then we come to outdated technology. In terms of quality giveaway losses, missed optimization, reduced efficiency, limited adaptability. Now, if the refinery don't adapt to the latest technology, which is moving at a very greater rate, they are left behind in terms of those tangible estimates. So it's all manual processes, outdated equipment, higher operational costs, missed opportunities, inefficient real-time monitoring, and it's about $70 to $20 million per year. Now these are depends upon at what stage your blending system or the other systems are staged. Now you might have to do the partial upgrade or the total upgrade. So that's why the range is between $70 to $20 million per year. So let's look at the whole picture. So we have blending operations, 22 million, oil movement, tank farm management, terminal operations, and down the line. And it's about $38 to $77 million or $40 to $80 million, roughly. So these inefficiencies are collectively represent a $40 to $80 million loss per year for a typically 300,000 barrels per day refinery. These are very substantial tangible benefits. So even if you take this one, say 50% of these benefits, your profit margin will increase by 3 to 5%. Now that's in terms of millions, and with the 10 refineries or corporation, is a huge profit. So, okay, we talk about where we're losing the money. Fine. How do we know those benefits, those numbers that I've shown you? How do we analyze them? So let's talk about one by one. If we take blending efficiency, how do we estimate this thing? There are three methods. We'll talk about three methods. First, refineries do the quality giveaway analysis. They look at the quality of the final blend, and they know the spec, and they look at the historical data, and then they calculate the giveaway. Now that giveaway is about about 10 to 15 million dollar for a badly run refinery. The second method we do is a blend reoptimization. Now, if they don't have optimization in the refinery, then the second method is just take those historical data and re-optimize the blends and see what they could have achieved in terms of optimal recipe, in terms of minimum giveaway, and re-optimize the past blend. And these are the typical method of doing that. And we are refinery or person who does that is using a non-linear optimizer model. So it's a very up-to-date technology. The third method is benchmarking. Now, some refineries says, okay, what you're saying is fine, but how do we know where we are? I mean, are we good, bad, or the best? Some refinery I've heard is saying we are the best. I say, okay, so let's do the benchmarking. Now, this technology was developed by OMS, where we can take the blending system and thoroughly examine each and every aspect of it, infrastructure, also in terms of efficiency. And then we develop two indices, which is infrastructure effectiveness and operational efficiency. And by this, we can compare two refineries or any refinery across each other worldwide on the same corporation. So there's a third method to know how much money you are losing or where are you in terms of the industry at par or you're below average or above average. Now we come to oil movement. Now, how do we estimate the oil movement benefits? First, we do oil movement analysis. We do historical data of all the transfers over 2-3 years, and we categorize them. That okay, which is the most highest number of transfers? In this case, which I did for a refinery in Spain, it shows 10 to tank transfer the highest, and which is typical in any refinery. And then we use the data to optimize the transfer frequencies. Can reduce that instead of doing from one tank to another, we can do different tanks, so that comes out of that analysis. The second analysis is that sometimes it's difficult to really put a figure on it, that how much money are we losing and what impact does it have. So we put four factors in there: manpower, automation, HSE, and tangible benefits. And we give different weighting factor to them. And with that one, we are able to come up with a average number or about within 90% accuracy number for each of the area. And this study also gives a very good idea to the refineries. Okay, how much money are we losing in oil movement, and is the ROI something that we can justify to automate the oil movement system? Sometimes it works, sometimes it doesn't work because they already did not do with the blending. So the project sometimes fail or doesn't go at all. So third method is that benefits by activities, and this using the key impact factors. This I talk about in the second method, and different transfer types, emphasizes that the oil movement is blending project should be executed together for maximum ROI. So implementing these three strategies for oil movement, you can achieve the efficiency and also reduction in cost. Now let's talk about tank form optimization. Almost every refinery nowadays have an inventory management system. It means they have a tank gauging system, and that tank gauging system gives inventory. Now, when we look at it, we also look at the historical data. Are we using the maximum storage in the tank, or we are just stopping 80% because we are afraid of the spills? So those kind of a analysis gives us the picture that how are we managing the inventory in the tank. It also gives analysis, are our tanks, number of tanks are sufficient in the refinery to do things. Sometimes you cannot create or install new tanks. It's too late. But what we have in the refinery can be optimized. So that analysis comes out of inventory management historical data. Secondly, minimizing tank analysis. It means now this is the topic which is a very critical in terms of blending. Now, what happens in typically the lab sample is taken from the tanks. They go to the lab. There's a time period, and they put in the system. Now, when the blending starts, that quality may be already outdated by half an hour, by 4 hours, 3 hours, 6 hours, or even a day. And when you blend and do the optimization, you are optimizing on the old qualities, not a correct quality in the tank. So this is the factor, and there are many methods by refineries can minimize and accurate the tank analysis for processes like blending, especially blending. Then second method is minimizing vapor loss. And that requires that how often do you load the tanks and how do you schedule them? Because every time you load the tank, the vapors are lost in the atmosphere and you have to measure them. You have to estimate them and report to the authorities that you're not emitting vapors out of the spec. So there are regulations. So you have to minimize also explosion. So those are the three areas of analysis. So in terms of optimizing tank form, it reduces the cost, optimizes usage of liquid assets, enhances safety, and boosts efficiency. Let's go to the terminal option. So in terms of marine terminal, the ships are very difficult to schedule because the refineries are not the only one. The ships start from the port of, they pick up the crude and then give it to different refinery on the pack. So refinery have to schedule that when will they come to the refinery. And if they have to wait for a day, it costs a lot of demurrage charges to the refinery. So the efficient loading and scheduling of the cargo is very important. And also that if you are getting the crude and making product and you're not delivering them to the customer in time, you're losing opportunity. So the cost of insufficient scheduling also plays a role. Then we go to truck terminal. Now, typically, if you see the truck terminal, there are about 300 trucks per day, which is moving in and out. And that's sometimes they are automatic to loading, or sometimes they're manual automatic. If there's a manual, then there's a problem of contamination or filling in the tank not per the order and maybe a little less. Now, we might think that 0.1% less product, it really doesn't matter. But now, if you look at the cost of that one, it's a lot of money. And customer then again says, okay, I order so much and I'm getting less. So those kind of lawsuits and disputes also comes into the picture. The cost of truck waiting times. How long the trucks have to move? They have to move because the more faster the truck moves, the more money you make. Estimate loss due to incorrect product loading. Reduce idle time by implementing automatic scheduling system scheduling. Now, the volume of truck terminal is huge. I'm talking about 300 to 400 trucks for a minimum 300,000 barrels refinery. So the scheduling and logistic have to be seamless. Then comes the pipeline terminal. Now, each of these terminal operations have their own challenges. Now, in a pipeline terminal, the products are shipped one after another. Say, for example, if you are sending in the pipeline to the customer 92 octane, and after that there is another customer waiting for 87 octane, you have to make sure the 87 octane does not contaminate 92 octane in the pipeline. And there is an area where they have to send it to slope because the mixing always happens, depends on the length of the pipeline and what order. So typically refinery have to schedule that they don't send the low grade octane product after the high grade to minimize the contamination. Sometimes they cannot help. So then they have to take it out of the slope and then reprocess again. And sometimes leakage also. So all of these have their challenges, but they have a methods of how to analyze them in terms of tangible losses. Then we come to the mass balancing, oil loss in some. So as I said before, the hydrocarbon balance is start from end to end, starting from receiving the component or crude and sending the final product to customers. So they have to implement the real-time tracking of material inflows and outflows from one end to another. And mostly they are at the truck, not the truck, that the ship cargo and the pipeline. They receive the crude also with the pipeline and they also receive by ship. I work for a refinery where there are about 11 to 12 types of crude coming by pipeline. And so they have to schedule it, which pipeline crude goes to which tank. if they're mixing or crude mixing, crude blending. They use a ERP system to automate data collection, to reduce the balancing errors, reconcile discrepancies, to do the accounting losses. Then we do a oil loss analysis. You can see all this oil loss on the flare, drainage, process, fugitives, tailgates, flare, pilers, and all those things. They all have to be analyzed. Now, these are aggregate. Some they do it for every month, not every day. Every day is sort of become impossible nowadays. So they do every month, and these are a lot of activity from lot of departments and lot of people involved in this thing. But when you look at the oil loss, then you look at historical data, how much you're losing and what are the sources of oil loss. I did a study for a refinery, and I took 3 years of data of this analysis. And believe it or not, they were showing the analysis as a loss or as a gain of mass. And that was because of the error in measuring, error of calculating, error of this thing. So those kind of things impacts the profitability of the refinery. So this I discussed before, that if you reduce 0.1 oil loss for a say example for 10 refineries, you're talking about 20 to 40 million dollar, if not more, in terms of oil loss. And most of the oil losses are in measurements. How accurately you do the measurements? They are paper losses, not real losses. But real losses also happens because of leaks and fugitive emissions and other things, and mismatch or balancing of the between tank to tank. So all the 3 methods are applied for calculating a tangible benefit for mass balancing. Then we come to maintenance and equipment health. The predictive maintenance. Why is important? Let me give you an example. In a blending system, to pump from one component, you require about 3 to 4 pumps, or sometimes at least one spare pump. Now, in the system that OMS designed, each pump is recorded how many hours it has work and when is the maintenance required for that one. So that's called a preventive maintenance. And so those kind of things are very important. You don't want to start the blend and you find the pump has failed because we're not maintained properly, or you don't have a spare pump. And I've seen all of it. Condition monitoring. Then some equipments are prone to failure because of vibration, thermal analysis, and refineries and maintenance department do all those kind of checks. These are regular maintenance or sometimes the scheduled maintenance. Assets life cycle management. You have to track the equipment lifespan, how long you ought to use them and before you replace them, not wait for the last minute. Use the historical data to extend assets life and reduce costs. Simulate performance with digital twins for better planning. Now, let's come to the final slide of environmental compliance in terms of how do we estimate the benefits. Now, for emission monitoring, nowadays everybody uses real-time sensor to track emission levels. And they are using iPad and phone to monitor in the field. Automate reporting to meet regulatory standards and detect non-compliance early to avoid fines. The waste management, it could be the slope, it could be the basement from other areas. So you have to implement recycling initiative because everything that you do costs money. And when it costs money, you lose the benefits. Then the water usage optimization. Water used in the industry, so you have to use it, you have to recycle it and reuse processed water, comply with the water discharge system to limit the environment contamination. So these are the 8 methods. We talk about 8 areas of benefits, how much they are, and then we talk about 8 areas where we can use different analytical methods to estimate those benefits. So let me give you a summary. Sorry, for technology upgrade, I missed one. So in terms of technology upgrades, nowadays the buzzword is digital transformation. Now you see a lot of literature, a lot of talk about it. And you have to use a digital transformation to implement advanced data tracking or to make decision, because if you get the information real time, you can make a decision real time. Automate repeated processes to boost efficiency. You don't do the same thing again and again, manually. Integrate LOT devices for real-time monitoring. System integration. Don't keep an island. Integrate them together. Connect all the systems for blending, oil movement, truck terminals, and terminals operation, everything, and do away with the legacy system. And if you have a legacy system, then connect them in a seamless operation. Implement ERP solution to streamline workflows, centralize data management for improve access and security. Next thing is using artificial and machine learning, artificial intelligence, machine learning. Now, this has become a very hot topic nowadays, but also overemphasized. We think that AI can solve every problem. No, it cannot. It's like a garbage in, garbage out. But if you use very wisely and with the focus of what you want to achieve, AI can certainly help you and can increase your productivity. In fact, OMS has developed a technique to use AI and ML for fuel blending without using analyzers. And we already have a patent pending on that one. And we have a project in the refinery to do a proof of concept of this one. So AI and machine learning is not going to go away. It's going to become better and better and better. But we have to use it with due diligence and with the full knowledge of what it cannot do. Now, let's look at the cross-reference of what method can be used for what industry. So on the left-hand side, uses analytical methods, what methods we talked about it. And then on the right-hand side, different areas where we can use it. And then I use the tick mark, which is more important, high impact and medium impact in terms of the color coding tick marks. So the one you see, the red marks, is as a high impact for each of the areas. And medium impact is good to have it, but it doesn't cost you a bundle. It does cost you something, but not cost a bundle. So use this chart to prioritize your methods and focus. So what have we learned so far? Refining the path forward. So we talk about benefits, we talk about how to estimate them, and then let's talk about what can we do. So we have learned that refinery profit margins remain volatile with uncertain prospects for the next decade. It's not going to improve. It might worsen or it might be stable. So we have to recognize that one. Then we realize that the offsite operation, which is typically ignored or not considered important, has a potential of $40 to $80 million in a refinery of 300,000 barrels per day refinery. That's there. It's your money you take. Then we explored methods to leverage historical data, how to really estimate it. Because unless you know for sure how to estimate it, you won't be able to justify. Now, surprisingly, all that I've said is still about 50% refinery in the world continue to overlook this opportunity. And they are not all outside US. There are quite many refineries in the US itself who are not doing anything to capture these benefits. So now we'll explore what is the factor called indifference toward these huge tangible benefits by, if I may call it, refinery management. Now, I always said and always heard this rhythm that those who know don't make a decision, cannot make a decision. Who can make a decision don't know. And that's a typical scenario in refinery operations. So let's see what indifference factor is. The definition is that we are accepting status quo. We are disregarding continuous improvement. And we don't want to change. We are in comfort zone. If it's not broken, don't fix it. That kind of attitude. There is no lack of accountability and absence of incentives, even though there is one, but we are ignoring them. The reasons? Low priority for offsite operation, and that's the biggest factor in the refining industry. Offsite operation by tradition, by decades, always ignored. They are not important. And this where makes the money. Lack of leadership commitment. Organization resistance to change. Oh, there's a risk. If I change something, it might break. Then what happens? So they don't want to take a change. Focus on short-term goals. Oh, I'm making money now. I have other projects very important, insufficient employment engagement. And on the fourth point, I want to mention, I almost did a study just last year on a refinery, and refinery commit mentioned that they are losing about 10 to 20 million dollar per year in the tangible benefits, and this was their number. So we propose a solution to them, and then they say, well, it's not important right now. We'll some other project. So they give away, and they never came back. So those kind of a focus on short-term goals, you take away the tangible and continuous benefits in the operations. Sometimes you cannot really know ROI from automation investment. And this is a company like OMS can help you. And we already talked about some of the methods where we estimate these things. How do we overcome the indifference factors in refinery operation? Leadership and cultural change. This is the education to the management. It starts from the executive to the manager to the operation manager. And promote accountability. We have to establish clear KPI. I was told once that my blending manager say that if you lose $100,000 per month in blending, it's okay. So they already approved. That is about $1.2 million per year. It's okay to lose. But it's not, they never pay attention that why do we have to lose $100,000 per year in blending? What can we do not do? But so they know accountability. Training and skill development. Now, if you do the search on internet, this becomes a factor, especially in 2 years of COVID pandemic, that people are not getting the skills. They are comfort zone. They don't want to learn anything, and management are not doing anything to upgrade their skills. And unless they upgrade their skills, how would they know the latest technology? How would they know how to correct their system to give them profitability? So that's the second factor which is causing indifference. Third is technology adoption and integration. Technology is sometimes too complex, too risky. They don't have a historical data to utilize to do the analysis, and they cannot do the automation solution. They are afraid. What if something breaks? Well, I mean, there is always a chance, but it's only fix it. So to reduce human errors and inefficiencies, invest in digital tools, implement digital platforms. The technology is there, but you have to have a sort of a burning desire, and also to be accountable to make money for your organization. So transforming indifference into proactive change leads to tangible benefits. So I will talk about more about what we are doing in terms of upgrading the skills of the professional. Our platform, which is called OMS e-learning, offers 200 plus courses for covering entire operations of offsite operations. We don't cover on-site operations. And we have different layers of executives to managers to engineers. And you can go for trainee, professional, expert. And those courses are very high end. And you can take on any device on any time, resume and start, just like playing a movie on Netflix. So, and you have a user interaction, you can build your own custom curriculum. So OMS e-learning is helping in that area to upgrade the skills of the professionals in the industry. We have different methods of free learning. There are many courses that you can learn by webinar, just like this one. You can take many topics and learn free monthly courses, series, free tests, e-learning, and then also hybrid live learning, where OMS teaches course in public or hybrid online, the recording and the plus live courses in the schedule or in person. So we have different venues to help the industry professional in their upgrading their skills and to contribute towards their own organization profitability. But knowledge is powerful. We have also a program where we give you trial access to refining industry. We have a program where we can give you full access across the industry, across the academy for 3 to 12 months. Your employees can take the certificates, you take the course, and then then the refinery industry can see that how this kind of program is helping the professional to learn new techniques and new skills and new knowledge. We also creating alliances with educational institutions. You all professionals listening to this webinar, we never learn operations of refining industry in our college days. So if the student is in the final year of chemical engineering and they go to a job market for an oil industry, they don't know what the industry is about. What do they do in the operation? So this is where we are helping the students in the final year and the fresh graduates to teach them. So when they go out for a job, they have a better knowledge. They are well equipped. And these are all free to the students and fresh graduates. The academy is fully open to them. Any course, anytime they can take it. So this is our contribution to the industry as well as the institution. So what are key takeaways? So we said the industry has a volatile profit margins because of pressure from rising costs and market challenges. We have to identify the lost tangible benefits, which is in the neighborhood of $40 to $80 million annually for a 300,000 barrels refinery. And then we have talked about how to do the analytical methods to estimate these benefits. We do quality giveaway analysis and predictive maintenance, optimize efficiency. Overcoming challenges, address the root causes of inefficiency, ignorance, outdated training, a resistance to change impact performance. Overcoming barriers, focus on leadership, upskilling, and adopting technology to break silos. Learning solution for industry professionals, where OMS e-learning provides structured courses to enhance skills and industry expertise. So as I said before, our academy focuses on refinery managers and executives to teach them that what is available in the education field, in the refining operations, and how they can benefit. So these are the courses which are very low number in topics and low number of hours, 4 to 8 hours, they can learn a lot. And by doing that, they're getting a knowledge that what are they losing. Second layer is operations supervisors, managers. Sometimes they're also not aware of what are they losing. They utilize benchmarking tools, real-time data analysis, embrace digital tools. Then come the engineer and technical specialists, who are the really people who understand that there's a lot of tangible benefits, and they are aware of the methods, but their hands are tied because 2 layers up, they don't really appreciate what is being lost. Then HSE, health, safety, environment officers. This is also important because they have to work about optimizing the vapor loss, implement real-time monitoring, ensure safety through technology-driven process control. How do we maximize ROI, tangible benefits? So key metrics to track ROI are annual savings about $40 to $80 million, I keep on saying, and payback period is 12 to 18 months. Maximum it can take 24 months if you do fuel blending and oil movement together. And you have a cost reduction up to 30% reduction in operating costs. Potential ROI from strategic improvement, quality giveaway reduction, oil movement optimization, and predictive maintenance. You can avoid $3 to $5 million in unplanned shutdown. Now, all these numbers that I've said in these webinars are come from OMS about 30 to 40 years of experience in the industry. And we have proven these numbers and we have calculated these numbers from the really historical data. So these are real numbers. You can use them to benefit your industry. So the one question comes, okay, is there any tool to estimate this benefit? Yes, we have created Excel-based OMS calculator, which is already existing, like fuel blending, oil movement, mass balance accuracy, blending system benchmarking. And then we are expanding this tool to create a centralized dashboard, automated data input, cloud-based, where you can estimate the benefits for your refinery from all the areas based on your refinery input and also different input types of input. So the benefit of this tool is you can get benefits calculated very easily rather than spending $100,000 in a consultant to do one area um, of the benefit. So towards the end, if you like what I presented you and you want to know more, just schedule a free consultation with me. We can talk to anything that was in problem in your refinery. We can suggest a solution to you. You can take courses on our academy, which are free courses. You can see the field, the quality, audio, video, subtitles, and there take the webinars. And then you can download our resources. We have a white papers, we have ebook. And other things. If you want more information, this is the information. You can send me email. You can scan the QR code to go to the site. This is the end of it.
Thank you, Dr. Growell, for a wonderful presentation. We have now concluded our presentation for Webinar-16. Our Academy has offered monthly webinars on fascinating subjects related to downstream refining operations. We will start the year 2025 with a fresh master series of webinars. Our first in the series will be Fuel Blending 4.0, Integrating Digital Twins for Refinery Operations, the 17th webinar in the master series, which Dr. Growell of OMS will present on January 22, 2025. The webinar will explore how combining AI/ML with digital twins revolutionizes fuel blending, eliminating traditional analyzers and optimizing real-time processes. Discover how digital twins replicate physical systems to ensure quality, cost efficiency, and compliance without expensive analyzers. Learn how AI-powered digital twins predict equipment failures and reduce unplanned downtime through real-time monitoring. Ability and efficiency to understand how this approach reduces emissions, improves resource use, and increases profitability while maintaining high product quality. We will now begin the question and answer session. You can email us any more questions at the email address below and the ones you posted in the conversation. We will ask you 2 poll questions with single and multiple choices for candid comments following the Q&A session.
I don't see any questions here. Just a comment from Umesh Mathur. Umesh, thank you very much for your nice words. And I think you and I have discussed these problems and seen in our careers. And you confirm that these examples also in your career. So thank you very much. Okay, if there are no new questions, we can start the poll. Please take a few minutes just to give us your answer here.
Would you kindly take a moment to respond to 2 multiple choice questions? First, what do you think is the main reason for missed opportunities in optimizing refinery offsite? Second, which of the following best describes the reason behind resistance to adopting new optimization strategies in your organization? We will now begin the poll.
Okay, we'll thank you. We'll end the poll.
We will close the poll now. Thanks for participating in the poll. Your answers will give us insight into our webinar content. Our complimentary gift is an ebook with 250 plus pages after you complete the survey. We provide a free 1-hour consultation with our academic director, the webinar presenter, Dr. Suresh Agrawal. Please take advantage of this chance to talk to him about any problems you are having in your refinery, or how to sign up with our academy to receive the benefits of e-learning. We hope to see you at the upcoming webinar. When you exit the webinar, it will lead you to the Google survey form, where you may provide us with insightful comments. Thank you, and have an excellent remainder of your day or evening.